So we know what molecules are. We now have to figure out if they're ionic or molecular. We know an ionic compound is one where the electrons are transferred. One of the things is pulling much harder on the electrons than the other, so it takes the electrons. Molecular or covalent is when two atoms share electrons. Not necessarily share them equally. Electronegativity plays a part, but the electronegativity is not strong enough to pull the electrons away. So the first step is deciding what it is in order to decide how to name it. Is it ionic or covalent? We start here with CO2. We see the C and the O. They're both nonmetals, so this molecule is covalent. In MgCl2, we have magnesium and chlorine. One's a metal, one's a nonmetal. Big difference in electronegativity. This one is ionic. And we would name it using the ionic system magnesium chloride. The next one, MnO2, has Mn and O. This one's weird. It's a metal and a nonmetal, so we can consider it manganese 4 oxide. However, we'll look at it again later. PCl5 has phosphorus and chlorine, both nonmetals. This one's covalent. N2O5, nitrogen and oxygen, again two nonmetals, covalent. And chromium and oxygen, metal, nonmetal, this one's ionic. So we realize that we need to name covalent molecules differently. We use prefixes to indicate the number of atoms of each individual element. For covalent compounds, we use prefixes. Mono means one atom, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Sometimes, depending on the element, we drop the last vowel. So this first one, CO2, we call carbon dioxide. The dioxide, di because there are two oxygens. There's no mono in front of carbon because if there's ever only one atom as the first element, then we drop the mono. Carbon dioxide. This next one's odd, MnO2. Although it's a metal and a nonmetal, their electronegativities really aren't that far apart. It's almost always considered covalent, and this is called manganese dioxide. Again, two oxygens and one manganese. The next one, PCl5. One phosphorus, so it's just phosphorus, pentachloride. The last one here, N2O5. Dinitrogen pentoxide. We drop the A in the penta because oxide starts with an O. Nitrogen pentoxide. So the key to this is first identifying if it's ionic or molecular. If it's molecular, count how many atoms of each kind there are, use the prefixes, and name it. Notice, however, the second element in the pair always changes its ending to IDE, just like in the ionic. However, we use the prefixes to count how many of each one there are.